suppose now that this object is moving on a table with the preceding forces, the drag force on the velocity and the restoring force on the position, and we also tilt the table progressively in such a way that we get another force which is mg cosine of omega t. Don't worry too much about what omega is, or m or g. This is just an expression. The point is that it includes the variable t. In this case, our equation becomes F net equals force of friction minus c times the derivative of position, or c times the velocity, minus kx plus mg cosine of omega t, which rearranges as indicated here. All these terms are similar to what they were before, and when we divide through by the m in front of the g goes away and we end up with g cosine of omega t. And that's simple algebra. The point now is that the form of this function is still x double prime equals some function of f, some function f of t, x, and x prime. And now in this example, t, x, and x prime are all explicitly part of the function f of t, x, x prime. Whereas in the preceding examples, t was absent here, and both t and x were absent here. And the point is just that x double prime equals f of tx x prime is the general form covering all these cases, and it's the general form of an ordinary differential equation of order 2. Order 2 because we're relating the second derivative to the lower derivatives and the variable with which we're taking the derivative.